All right, so after some tedious algebra, I was able to arrive at an answer for I2. So I got I2 as an expression of V2 here, and then I went and resolved equation 2 for V2. Once I plugged in this expression for I2 into here, I got this, and I went and carried out the algebra all the way until I found an expression for V2, plugged that into my expression for I2, and I was able to get this phasor for I2 here, okay? And so then the final part of the problem basically tells us to determine the power delivered, or they don't specify whether it's average power or not. I'm going to assume that it's average power. So all we have to do in that case is 1/2 times the magnitude of I squared and then multiplied by RL. Okay. If you have any questions about this, you can see example 11-2 on page 606 of the ULB book. They use this same formula here for average power delivered to a resistor. So that's the equation I'm using here. And so all we have to do is PRL is going to be equal to 1/2 times 0.24 squared times our load, which is 144 ohms. Okay. Of course, that's because this current I2 is the current that's flowing through RL, right? So it's just average power delivered to that resistor. And so I can say 0.24 squared divided by 2, and then multiply that by 144, and I get 4.15 watts. Okay, so that's the average power delivered to the load. All right, so that is our example problem. I think I have maybe one more slide here before we get into some practical notes on transformers, but we're almost done with this module. In the next video, I'm going to talk about multi-winding transformers and just kind of touch on those. Pretty important concept in this module, but just going to touch on it real briefly. It's nothing crazy. It's just basically the concept that we can have multiple windings on a core, basically multiple secondary windings. You can think of them as sometimes the third winding is called the tertiary winding, but we can talk about that in the next video. So I'll end this video here.